We begin now a series of videos on redox reactions. The definition of a redox reaction is a reaction in which electrons are transferred between various atoms. A way to characterize redox reactions is to actually figure out what atom is losing electrons and what atom is gaining electrons. And this can be done with something that is called the oxidation number. Okay, so in this video we're going to see the rules to determine the oxidation number of various atoms in molecules, in compounds, and then we will do a few examples to solidify those oxidation number rules. Okay, so to start with, we can say that all of the elements, whenever you have a reaction in which an atom appears in elemental form, the oxidation number will be 0 for all of the elements. Okay, so again, when you have an element in a chemical reaction, elements, the oxidation number is equal to 0. Okay. Now, what happens with when you have oxygen in a compound? All right. So for oxygen, the default oxidation number is going to be equal to 2. Actually, minus 2. Minus 2. Okay, but there's a couple of exceptions. One of them is peroxides. Okay, so for peroxides, the oxidation number is going to be minus 1. Okay, an example of a peroxide is hydrogen peroxide, H2O2. Okay, and the second exception is a series of compounds called superoxides. Okay, for superoxides, the oxidation number is going to be equal to minus 0.5. Okay, and these are both peroxides and superoxides are very uncommon. Okay, but for example, an example of superoxide would be KO2, okay, potassium superoxide. And again, we're just using this as an example, but they will be extremely rare. For peroxides, hydrogen peroxide is perhaps the most common compound that we're going to see in redox reactions. All right, so we have knocked out oxygens. What about halogens? All right, halogens. The oxidation number by default is going to be equal to minus 1. But there is an exception here as well, which is what happens, that exception happens when you actually have an oxygen ion. So if you remember those hypochlorite, chloride, chlorate, and perchlorate, those are examples of oxygen ions. In that case, we'll actually see in the examples how do you actually go about characterizing the oxidation of halogens. But if you're not, that halogen is not in an oxygen ion, then we're going to give it an oxidation number of minus 1. Okay, what else? Hydrogen. All right, hydrogen is going to have an oxidation number of plus 1, okay, unless it's bound to a metal, bound to a metal. In that case, the oxidation number is going to be equal to minus 1. Okay? So for example, in acids you actually have the hydrogens bound to, those protons are bound to oxygen atoms. There will be an oxidation number of plus 1. But if you have a hydrogen atom coordinated directly, bonded directly to a metal, then there will be a minus 1 oxidation number. Okay. A couple more rules. We're going to have here that alkali metals, okay, those have oxidation numbers of plus 1, and alkaline earth metals are going to have an oxidation number of plus 2. Okay, now comes perhaps the most important rule. When you have a compound with various atoms and you're trying to determine the oxidation number of each one of the atoms in that compound, the sum of the oxidation numbers of all of the atoms that you have multiplied by the stoichiometric coefficients, okay, that has to be equal to the charge of the molecule. Again, the sum of the oxidation numbers multiplied by the stoichiometric coefficients has to be identical to the charge of that compound. Okay, I'm not going to write this rule here, but we're going to see it play in just examples that we're going to be doing here. All right, so let's do a couple of examples here to solidify these rules. Sodium chloride. And this is fairly easy because you have here a halogen, which we know is -1, and then an alkali, which is +1, right? So the oxidation number of sodium is +1, oxidation number of chloride -1. Okay, notice that the sum of the oxidation numbers in this case is equal to 0, which is great because that sodium chloride does not have a charge. Okay, so those are the oxidation numbers of sodium and chlorine in sodium chloride. All right, let's increase here the challenge a little bit. Okay, by trying to figure out the oxidation numbers of this compound. That is sodium hypochlorite. Okay, so we know that the oxidation number of sodium is +1, is an alkali, and we know that the oxygen oxidation number is equal to -2. Okay, so now you have a halogen here, and you may be tempted to attribute a -1 oxidation number to that chlorine. Okay, but notice that this is an oxo ion, right? It is hypochlorite. Okay, so then that rule does not apply anymore for the halogens. Instead, here you have to be guided by the fact that the sum of the oxidation numbers has to be equal to 0. All right, so in order to make that happen, the oxidation of number of chlorine in that compound has to be equal to +1. Okay, so again, you can see how these rules come into play with these examples. All right, let's do a couple more. Let's do here KNO3, which is potassium nitrate. Okay, potassium is an alkali, so you have a +1. Oxygen is going to be a -2. Okay, but notice that here you have 3 oxygens, right? So the total oxidation number in oxygen is going to be -6. Okay, in order to make that 0 and agree with the neutrality of that compound, okay, the oxidation number of nitrogen has to be equal to +5. Okay, notice that then the positive oxidation numbers would add up to +6, and then you have 3 times -2, -6, +6 with -6 cancels out, which is exactly what you want. Okay, so those are the oxidation numbers in potassium nitrate. And the last example is going to be permanganate. Okay, the permanganate oxone ion. Alright, so here we have an oxygen by 4. Okay, the oxidation number of oxygen is going to be -2, but the total oxidation number from oxygen is going to be -8. Now, here we have a negative charge right there, right? So then, if we attribute an oxidation number of +7 to manganese in that compound, we'll have that the total sum of oxidation numbers is equal to -1, right? +7, and then -2 by 4 is -8, +7 -8 gives a total oxidation number sum of -1, and that agrees with the charge of the compound. Okay? So again, in this video, we actually have defined what a redox reaction is. It's a reaction in which you transfer electrons from an atom to the next, and that be characterized by something that we call the oxidation number. There are rules to determine what the oxidation number of atoms is in compounds, and we have done a few examples to exemplify those rules.